first keynote. We're very pleased to have Michael Cotton as the first keynote speaker, and he's going to talk about the title of his keynote today is NTIA ITS Research and Development Applied to Spectrum Management. And Michael Cotton is a division chief for the Telecommunications Theory Division at the Institute of Telecommunications Sciences in Boulder, Colorado. And he leads the Spectrum Management Research and Development Program in support of NTIA's Office of Spectrum Management. And Michael also leads NTIA's Spectrum Monitoring Program. So with that, without further ado, Michael, you have the stage. Michael, if you're there, you
there
can
we go.
unmute.
Okay.
Yes, perfect. All right, great.
Thanks, Kaushik. I appreciate that. So I'm honored to be included in the workshop, and I really appreciate the efforts of setting it up. And I'm happy for the opportunity to sort of share my perspective as an NTIA scientist. Maybe one small correction is that I won't be talking NTIA policy. I'll give some overviews of NTIA spectrum management, but in my capacity, I am a scientist, so please don't take it as NTIA policy, because I can be kind of a sharp-end guy at NTIA, so I don't necessarily get the policies all right. But my goals here are to kind of give an overview of spectrum management in the United States, really kind of more on the federal side. I think that this community is very in tune with the commercial side of spectrum management, so I wanted to kind of give a little bit of a description of how spectrum management works on the other side. And then I want to describe, like the title said, about some research that's applied to improving spectrum management in the US, and then maybe just take a few words to describe how I feel like we align with the NSF Spectrum Innovation Initiative. So starting off, so spectrum management is a bifurcated system in the US where the FCC manages commercial and the NTIA manages the government side. So the NTIA and the FCC coordinate on international and domestic issues. At the highest level, the Assistant Secretary at NTIA meets with the chairman of the FCC on a biannual basis. And at a staffing level, there's sort of regular exchanges, and there's sort of some expectations set by MOUs and so forth like that. NTI and FCC both have advisory committees that provide industry and university expertise and perspective on reforms, on new technologies, and advancing spectrum management. For NTIA, it's CSMAC, the Commercial Spectrum Management Advisory Committee, and for the FCC, it's TAC, Technological Advisory Council. And I think this last year, CSMAC covered topics like spectrum for unmanned aircraft vehicles, and interference prevention, and mitigation and resolution. I think that there was a governance subcommittee within CSMAC, which basically is rewriting the overview that I'm giving right now. And then there was one other one, I think it was non-federal, new future rules for non-federal spectrum users. The NTIA Assistant Secretary also chairs the Policy and Plan Steering Committee, which is PPSG, which is consisted of assistant secretaries and their equivalents for a number of agencies who are major spectrum stakeholders. Also, the FCC and the White House is there. And largely, that's where NTIA drives spectrum policy discussions and coordinates those discussions that come from directives from the White House. So they also publish, PPSG also publishes an annual report. I think since 2018, there's a report entitled Status on Spectrum Repurposing. So, you know, if this community wants to see where NTIA policies are, you know, that's a good place to kind of take a look at the bands that that are listed in there. Okay, now to get a little bit into the nitty-gritty, NTIA has a manual of regulations and procedures for federal radio frequency management. We call it the NTIA Red Book. It is available online. It contains text on international dependencies, tables on frequency allocations and allotments, spectrum standards, definitions, and procedures. So there's a little bit of a different terminology that is listed in there and compared to the FCC side of things. So I'll just maybe provide a couple of definitions. Allocations are band designations for allowed types of radio systems. There are allocations that may be primary or secondary. Every band has at least one primary allocation. There are many bands that have multiple allocations in primary services, co-primary services, that is, and there are many bands that have secondary services as well. An example of an allocation would be radio location or radar in the 27 or 2900 megahertz band. And then the other thing, which is the other term, which is sort of analogous to FCC licenses, are assignments, which are permissions basically to operate individual government radios or specific government systems. So assignments are filed into what we call the NTIA government master file, which contains not only government assignments, but also assignments from non-government systems that operate within government primary radio bands. Okay, and then assignments have to basically be consistent with allocations. So an example of an assignment is a single ASR9 air traffic control radar operating at 2730 megahertz and 2860 megahertz at Dulles Airport, for example. So it's just kind of the very specific assignment or permission. So NTIA has, I'm from the Institute for Telecommunications Science. NTIA also has an Office of Spectrum Management that chairs the Interdepartment Radio Advisory Committee, or IRAC. So the basic function of the IRAC are to assist the Assistant Secretary in assigning frequencies for government radio stations and developing and executing programs, policies, procedures, and technical criteria. So the process is basically the agency file applications with OSM's Spectrum Services Division, which for consideration at the IRAC Frequency Assignment Subcommittee. So the Frequency Assignment Subcommittee considers pending items on a monthly basis and takes action according to established guidelines. The meeting minutes from the Assignment Subcommittee, Frequency Assignment Subcommittee, provides minutes to the Associate Administrator of OSM, and if there's approval there, then it is filed within the GMF file. So, you know, there's for matters that are of considerable importance, IRAC will move things up to NTIA to consult with the FCC and appropriate agencies. Government applications are not heard by the public because, for security reasons, basically there are classified and unclassified assignments in the GMF. The FCC basically represents the public, and they can object or concur or give tacit approval. At a more local level, agencies have spectrum management offices. So in Boulder, for example, we have a Boulder Labs frequency manager, which is responsible to coordinate all federal use of radio frequencies on the DOC campus and the Table Mountain Radio Quiet Zone, for example. So tasks for frequency managers, they resolve on-site interference issues. In Boulder, we have a radio frequency management committee that we use. And then the frequency manager also requests special temporary authority for operations that are less than 3 months and that are experimental by nature. So SDAs are not recorded in GMF, nor are they run through the IRAC process. They typically take somewhere around 4 weeks. And also the frequency manager processes a request for permanent assignments, running things through the IRAC, and that process typically requires 6 to 8 weeks. So I just wanted to go through that a little bit to provide just a general overview of the process of spectrum management and give you some details about kind of how much time it takes and how many people it needs to hit and so forth. And, ITS, what we try to do at ITS is work towards making that process go faster by creating a pipeline of R&D that works to provide trustworthy models and data so that we can start to automate things within that process. So ITS has been around since the radio sector of the National Bureau of Standards was funded in 1916. We focused on radar and for World War II, and then we went over to propagation, a focus on propagation, all the way until we joined NTIA in 1978. So that 1978 is when we really became applied in kind of a regulatory framework. So we're 70% funded by other agency work. And so that kind of describes how we operate. We are very lean and applied, and we have a lot of experience with agency systems and the issues that they face. And one of our most important sponsors is the Office of Spectrum Management, our sister agency that runs through this process like this. And I want to talk a little bit about 3 specific ERIC topics that we're working with in OSM towards this end. Towards the end of embedded and proactive spectrum management versus manual and reactive spectrum management practices. I want to introduce first that NTIA has an official propagation code library. So I started running the theory division about 5 years ago, and I formed a propagation focus group where we brought the experts together on a regular basis for mentorship and for cross-project kind of discussions. And what we quickly found out was even just on our hall, we would have 5 or 6 different implementations of models that are basically considered standard ITS models. And so I kind of challenged the group and was saying, how the heck are we supposed to improve these things if we have 6 different implementations on that? So since that time, we've really worked hard towards single implementations of those models and open sourcing them to the public. So we support them. We develop them within C++ and the NuGet dependency management system to offer common language support across most operating systems and platforms. And we basically take those models and we run it through the scientific process here at ITS so that we can run experiments towards validation and improvement of those models and continue to improve those things as we move forward and evolve them. So the models that are available now were EHADA, extended HADA model, which was used within CBRS, and then also P528, which was within the ITU recommendation space. So, for example, last year at the ITU, the ITU approved that the NTIA implementation is an integral part to that recommendation. So anybody that's using P528 should be pointed to the ITS GitHub repo where they can download the official version. By the end of this fiscal year, we're going to be releasing an ITM, the irregular train model for long distance terrestrial paths, and then IF77 for our air-to-ground paths, and also an LFMF, low frequency, medium frequency model to support the community in the ITU. Okay, so the next topic I want to talk about is spectrum monitoring. We are standardizing the software stack for spectrum monitoring within IEEE 802. We've taken that software stack to a maturity level where we will be offering an NTIA spectrum monitoring website that allows for authorized users to request measurements for the associated production level sensors, and also download data from those sensors. So the sensors that we offer behind this website are heterogeneous, so we're offering kind of a common language to talk to different sensors that have different hardware behind them, and basically discover what they can do in algorithm and in hardware measurement. That's our production level system. Basically, we're meeting NIST 800, so it's secure. We have a government website that offers that. So there's been a lot of work towards meeting government IT security requirements there. So I think that that's a really nice precedent for us. I think we'll be conservative at first in the authorized users that we open it up to. It'll be government users only, mostly OSM for the first bit, because I think we still need to address a lot of the privacy and security issues around data before we can start to make this more opened up. But again, I think that it's really an important accomplishment. Behind any production level system, there's a development system. And so we have, our development platform is within Boulder. We have 10 sensors that are operating on campus up at the Table Mountain Radio Quiet Zone, and we have an agreement with CU currently where we have kind of a neighborhood density of sensors around campus there. It's all fiber connected. We tunnel through the CU network so that we can go from the fiber that goes underground at Boulder up to the rooftop. And basically, we're going to extend that number to start creating a bit better density of sensors around Boulder. And we're looking to basically support the Boulder Frequency Manager and try to work towards giving them some better RF awareness so that we can start working towards automation and really having those spectrum managers have data at their fingertips. And now I'm getting a little bit late, but I did want to touch on one other subject. It's called spectrum efficiency, spectrum resource efficiency. And it really gets into data analytics around spectrum management, and it bubbles up a lot of the spectrum efficiency issues up out of the engineering level to the economics level. So spectrum efficiency for a long time has been all about sort of technology performance. The units are bits per hertz, for example. And that makes it really difficult to do any kind of efficiency of this on spectrum resource usage, because you can't really compare different services, right? You can't compare bits per hertz of a broadband comm system with like a radar system, which has a whole different set of metrics, performance metrics. So what we've done is we've kind of created a new framework where we're not necessarily asking how high of a performance can you get, but what is your performance criteria to gain your mission? Define your mission and what is your utility requirement there. And once you have that, you can start defining things like utility space to accomplish that mission, or utility frequencies of bandwidth to achieve that mission. And then to create a spectrum resource efficiency metric would be a matter of having the utility, the space where you need utility over the space that you occupy. So if you have a really loud transmitter that's blasting signals out for hundreds of kilometers, but really you're only gaining utility within 10 kilometers, that's going to be a highly inefficient system in the spatial domain. And we'll do the same in frequency. So we'll talk about band packing. We'll ask questions about those systems to see what bandwidth is required, and then we'll talk about what bandwidth is being occupied, and we'll be able to assess. So it's kind of a simplification and a focus more on the spectrum resource efficiency as opposed to the technology. So we're looking to evaluate that in NextRad for a simple case like NextRad, where we can take a look at sort of static locations of systems, and then we'll address some things such as band packing to move those closer together, assess that. And then what becomes a little bit more difficult is the spectrum sharing scenario where we start to introduce a different service, and the formulation becomes a little bit more complicated that way. Okay, so I have a few closing comments, but maybe I should look towards the questions real quick. I think that's what you want me to do, Kaushik, right?
Yes, absolutely. So for example, we can start, and by the way, thank you very much for this talk, much appreciated, lots of great new insights. So we can jump right into the questions, and you see the questions in the general chat window. So I'll let you go ahead and pick the questions that you would like to talk about. And
okay, so what is the procedure to get access to the sensor data? So there is a procedure where you'll have to fill out a form, and we are just starting that whole process up. So I actually wouldn't say that there's hope that we'll be sharing the data quite yet. So I think that, like I said before, we're going to start on the government side and move that. But there is a formal process that aligns with the NIST security controls that we talked about. The right person to collaborate on channel propagation models, I think it said before it moved out of sight, was so the propagation, the lead for the propagation focus group is a gentleman named Billy Kozma within my group. And shoot me an email. I can forward you contact information for Billy.
So Mike, just one clarification there. So Bindu, who asked this question, is also at MITRE. So there could be a different, maybe a different mode of sharing, because MITRE often works closely with federal agencies. So it could be it could be a different model than the rest of us when it comes to data sharing.
Okay.
But I think you guys can take it definitely offline on that.
Yeah. Thank you.
Great.
So
Mike, moving on to the next question, Mike.
Yep. So spectrum efficiency focus on should spectrum efficiency focus on applications? I think what you're saying is radio services, or are you talking about application? So, okay, let's take the NextRad radio service, for example. There are a number of different modes that NextRad has. I think on the first, what we would do is kind of try to define the mission for a certain mode and maybe assess the efficiency for that mode. And as we go through the different, if there are different requirements, I think what we would probably do is look at the most sensitive, or maybe the case or the application of NextRad that has the most challenging requirement. For example, it needs the highest signal to noise ratio or something like that to achieve a certain level of detection. So I do think that application is part of the mission definition.
Okay.
Thank you for your talk. What do you think about possibility of shared spectrum usage between mission critical government applications? So yeah, I mean, NTIA is moving forward on a lot of spectrum sharing fronts between mission critical government applications and Wi-Fi and cellular communications. That's a lot. There's a lot of work that's going on there. I mean, one of the most important entrants is basically 5G. Hello, Maria. I haven't seen you in a long time or talked to you in a while. Information management system. Will there be a way to establish a ground truth for the spectrum traces, a priori knowledge of transmitter properties for transmitters present in the scan? Will there be capabilities for controlled transmissions, or is it entirely passive? So this is great. So great question. Really what we're working toward in this next year as NTIA is having a better understanding of what the transmitters are in the local area. So I think one of the important things that really NTIA needs to work on is it's just like environmental conservation, right? You need to think globally but act locally. And I think that what's going on within NTIA is this GMF file, which is this, it's very incomplete information. It needs improvement, right? It needs validation. And that validation, you know, some of the projects that we're talking about here are going to help with that, I think. So spectrum monitoring, get an idea of what the transmitters are from the GMF, and then validate those things, right? And start to work towards keeping all that honest. And then, you know, we can also put propagation models in there and do some scientific experiments around that area and start to really improve a lot of the tooling that we offer in spectrum management. And then really start to help support the spectrum managers, the local spectrum managers like we have there. And what we're trying to do there really is make a modular spectrum management infrastructure that can be redeployed in other areas. And so this kind of fits with that whole National Radio Dynamic Zone spectrum. It also, in my opinion, fits with the PAR framework, where, you know, we need more and more flexibility in spectrum management in these local spaces for these different purposes, whether it be experimentation or testing or training for that matter, because DoD, for example, really requires, they have some applications where they could use a little bit of flexibility in their spectrum usage. So create some infrastructure so that, and improve spectrum management in this local space so that, you know, in a larger sense, things get loosened up and become a little bit more flexible and facilitate a lot of the more advanced things that happen. I got a little bit off your topic, probably a little bit there. But yes, we will try to work towards a priori knowledge and coupling that with our sensor work. How do you account for the heterogeneity in spectrum sensor, especially in terms of sensing, sensor quality, and data fusion? Okay, great question. So we have on our GitHub repo a data specification, which is a namespace that we're adding onto the SIGMF open source repository that GNU Radio put out. And basically, our SIGMF namespace is based off of RF measurement best practices. So we really try to provide examples with our data that provide contextual information about the equipment that's being measured. I'm at the end of my time slot, but this is just a really important point. And what we're trying to encourage is, as if other people start to deploy these sensor networks, they work towards adding the same contextual information to that sensor data so that we can really focus on data reuse, right? It's so much wasteful to just sort of migrate data from one spec to the other. So we're trying to standardize that data spec so that we can get past the migration stuff and start thinking much bigger about the data, start integrating and aggregating over larger data sets so that we can apply it to things like machine learning and really start working towards the common benefit. I think I'm out of time, Kaushik.
Well, there is this one last question. We should not just let that last one slip by. So I'll go ahead and let you take it.
Okay. What are the major obstacles from your point of view for more agile and dynamic spectrum sharing? What is missing right now from the technological point of view? Honestly, I really think, you know, in terms of the wireless technological systems, I think the systems are very becoming more and more adaptable. NTIA has got a lot of work going into understanding LTE and 5G at across all the layers. So we have, I think Todd Schumann is a colleague of mine that's joined this workshop as well. He's got an LTE test bed going there. So we're learning more and more and becoming more intimate with how adaptable these systems are on the commercial side. I honestly think spectrum management needs to become more flexible. Like I said, we really need automation. We really need trustworthy tools and practices within spectrum management so that we can facilitate, keep pace with the technology that's being offered up.
Mike, just a quick follow-up of Koshik. Like, you think it's research challenges or it's more engineering, right? So you just need to put more engineers on this, or is there like any research gaps that needs to be closed for that, for this dynamic spectrum management? What you mentioned.
So I think, so one thing about spectrum management is what we need are tools that are trustworthy. Right, so it's a path that we need to take past. We need to move the research past proof of concept. It needs to be standardized. It needs to be agreed upon amongst the community, amongst the agencies, amongst all the people that are deliberating on these spectrum management issues. So what I feel like is very, very important is what we work hard on at ITS is creating a pipeline, right, where we interact with OSM, with the spectrum management stuff, and we move the research. I mean, there's a lot of that sharp end stuff that we're talking about signal identification, geolocation, improving our propagation measurements, testing different technologies, you know, all of these things that I'm sure we're going to talk a lot about over the next couple of days. But it's got to get hardened, and it's got to move a little bit so that it's got to be made easy. Because spectrum managers aren't necessarily the people that are as technically savvy as where the research is happening, and it's got to be be pushed over to higher levels.
Thank you, Mike. If that answers the question, thank you very much for the incredible keynote talk.